Okay. In units 1, 2, and 3, and whatever your next chemistry class is, these are some really good steps to follow. Whenever we have a problem, it's always a word problem. Always. That's the problem with problem solving in science. It's a word problem. At least in math class, when you've got the equations and this and that. And then they go, oh no, it's a math problem. I mean, a word problem in algebra. And they always just give me the formula and everything. But in chemistry, physics, engineering classes, they're all word problems. Okay, so as far as chemistry goes, balance the equation. If there's no equation, skip number 1. What is given and what are you trying to calculate? So you just go through there and make sure you figure out what's given and what you're trying to calculate. And then the last one is a series of conversion factors. Also note, there are 3 types of problems. One is, I call it linear, something like 12 milligrams is how many pounds? Okay, there are also fractions. If the given is a fraction, then you're trying to calculate has to be a fraction also. And I'm going to show you when I go over those examples, is it's actually 2 problems. You basically do one numerator problem and another denominator problem. And then lastly, also look at whether it involves square units or cubic units. Because you have to convert a linear conversion factor to a squared conversion factor to a cubic conversion factor. Not sure how to do all that. I'm just saying those are the 3 main types. Also, whenever you see the word per, red flag, that means that's a fraction, that's a conversion factor. So frequently they'll give those buried within the word problem. Like miles per gallon, miles per gallon. So you see the per, think fraction. And the per is a fraction bar. Also, when you draw your fractions, draw them as a horizontal fraction bar, not a diagonal one. Because we're going to see sometimes it takes like 8 or 9 conversions to go from the given to what you're trying to calculate. And if you have diagonal fraction bars, it flows better if all of them are horizontals. Because like we did in Dry Lab 1, everything on the top we get by the multiply key, everything on the bottom we get the divide key. And if they're nice flat fraction bars, it's much easier to see how that goes. Okay, now, a lot of times other instructors will label this unit as unit analysis. And what they mean by that is they treat the unit, like pounds, grams, whatever, as a unknown. For example, if you multiply A times C over A, what's the answer? Yeah. C. Why? Why is it C?
Oh,
the A's cancel. That's right. So sometimes you'll see this unit called unit cancellation. And the reason why they call it unit cancellation is because they treat the unit just like we did here, like an A or a C. Yeah.
So basically you rounded the letters.
Rounded the letters?
Yeah, and you chose the one that is more round.
Yeah, for illustration. Yeah. Okay, so let's take a really hard problem. I know some of you in here have already had calculus. So this come in really handy for those of you who already had calculus. How many dozen apples are in 34 single apples? Now, all of you go, oh, you just divide by 12. But what if you didn't know that? Okay, so the given is 34 apples. That goes on the left. What are we trying to calculate? Dozen. Dozen goes on the right. Now, step 4 is the setup, series of conversion factors. So we need to go from apples to dozen. And we're going to use a conversion factor. Now, the conversion factors are all fractions. So whenever you see you convert that into a fraction. So and another thing is you always have two conversion factors. You have an inverse also. And the inverse is simply the for you math folks, it's the multiplicative inverse. Okay, so we're going to go 1 dozen over 12. So the question becomes, which conversion factor do we use? Okay, notice we want dozen to come out on top. So that means you're going to use a conversion factor where dozen is on top. Now, notice something here. When we use conversion factors, we want things to cancel. And the things that are going to cancel are the units. So, just like the AC we just did, the apples cancel. What does it leave? It leaves dozen. What are we trying to calculate? Dozen. So everything needs to cancel except what you're trying to calculate. If it doesn't, then your setup is wrong. Now, some of you, again, are very comfortable in math, and you may want to try some shortcuts. Shortcuts are great, assuming you get the right answer. If you don't get the right answer, and I can't follow your logic, you're not going to get any partial credit. If you do the setups by following these 4 steps, I can give you partial credit, assuming your setup's reasonable. Now, usually I can give you at least 1 or 2 points if your setup is sort of there. Okay, so if this was a problem on a test, how many sig figs is 1 dozen over 12 apples? It says 1. It's by definition. Hence, it's infinite. So how many sig figs is our answer going to have? How many? No, it's the smaller of the two. Which is smaller, 2 or infinite? 2. Okay. So our answer, my calculator gives me 2.8333333, 29. So I go to the third place, which is a 3, and round up. I mean, round down. So it's 2.8. Now, say this problem's worth 10 points on a test. The setup there was worth 9 of the 10. Not the 2.8. 2.8 is, can you use your calculator? It's not the important part of this class. The important part of this class is setup. Okay. So that's a very simple problem, but it goes through and illustrates all the points on those. Now, is there a chemical reaction going on? No. All we're doing is renaming it. So no chemical reaction, don't worry about it. Now, when we get into unit 2, there will be chemical reactions. Every single problem you do in unit 2 will have a chemical reaction. So step number 1 is balance the chemical reaction. You have to learn how to balance a chemical equation. And for those of you who had linear algebra, there are 2 ways to do the chemical balancing chemical equations, using matrices or guess and check. Sometimes guess and check is really quick, and the matrices, if you have a TI 83, 84, or 36, it does matrices. So you're going to have an extra credit opportunity for test 2. It's balancing a hard reaction. It usually takes about 90 minutes to balance this sucker. 32 seconds on the calculator using reverse row echelon format on the calculator. RREF. Okay. Or guess and check. That's the 90-minute. Okay, are there any questions regarding the setup of this thing? Okay, so every problem I'm doing today and tomorrow I'm going to do some really more complicated problems, but the ones we're doing today are basically going to be very similar to this. And I want you to look at a pattern. Given goes on the left, what we're trying to calculate is on the right. In the middle are the conversion factors that cancel out those units. And whenever you have a conversion factor, again, you always have the inverse of it. So one conversion factor means you have the inverse of it. Unit 2, unit 3, yeah.
What's the infinite significant figures? What was that for?
That's by definition, when anything's defined, it's infinite sig figs. And the dozen is defined. It's not 12.1, it's not 11.9, it's always 12. No exceptions. Now, on your conversion factors, which was the handout today, is this here. Now, everything in boldface is by definition. So all those boldface, including this one. That's boldface, it's not as obvious as the other one. So those all have infinite significant figures. Now, this is the same thing that's in DryLab 2, page 1. The problem with DryLab page 1 conversion factors, all the ones by definition are italicized, and it's really hard to tell which ones are regular versus italicized, where mine is slap you in the face, both. The other thing, I expanded the whole metric system, a little chart he had. So, and you're welcome to use either one, because they're basically the same thing. I just thought mine was easier to read. Okay, so we're all okay with this apples to dozen, right? Okay, how many inches are in 34 centimeters? Okay, what's given? We're trying to calculate what? inches. So we need a conversion factor with centimeters and inches in it, if possible. Now, if we don't have conversion factor with inches and centimeters in it, it's going to be a multi-step problem. Sometimes it's like 8 or 9 steps, for example. Now, you're going to have a take-home problem with this test. You're going to have take-home problems for test 1, 2, 3, but not 4. And that I'll give it to you days in advance. We have plenty of time to do it. Okay, and then you bring it on the day of the test, and when you hand in your test, you just staple it to the back. Okay, so we need a conversion factor that's got centimeters and inches in it. Let's see. Do we have such an animal over here? We do. Look at that. It's also bold-faced. So that means it's infinite sig figs. Now, we convert it into a fraction. So it's going to be so we want to end up with inches on the top. So we want the conversion factor with inches on the top so that the given always cancels. The given always cancels, which means it's got to be in the given's got to be in the bottom. So in this case, centimeters needs to be in the bottom. And inches on the top. So that means we're going to be using this guy here. Centimeters cancels. What are we left with? Inches. What are we trying to calculate? Inches. And sig fig wise, we're going to have 2 sig figs. So our answer could be 13 point or 13. Either way is fine. Now, the pattern is the first conversion factor's got to cancel the given every single time. Unless we're doing fractions. The given's a fraction, ends with a fraction. So that's 2 separate problems. Secondly, everything has to cancel except the unit we're trying to calculate. Every single time. So in your setup, before you put any numbers down, anything in your calculator, make sure your units are canceling properly. Okay. How many miles in 12 inches? Yeah. Well, 34 is how many sig figs? 2. 1 inch is bold-faced, 2.54 centimeters, which means it's infinite. Over here, the
Right.
no, that's just for your clarification. You can write it if you want. I'm not looking for that. That's a good question. Same with your answers to, it's if you've never done sig figs before, it might be helpful for a while to do that. But if it's there or not there, I'm not gonna mark off them. Okay? Okay, so we okay with this guy? How many miles are in 12 inches? Now, your textbook, this is chapter 2 stuff. And your textbook does this almost exactly the way I do it. They call it strategy. Basically, it's unit cancellation. You've got to cancel everything. So you're left with one unit. Except for if you're doing a fraction problem. And that's what you're trying to calculate. Okay, given's 12 inches. Trying to calculate miles. Okay, again, we're looking at okay, we've got feet in a mile. And we know 12 inches to a foot. So those are our two units. Unfortunately, they're not in one unit, though, one conversion factor. That means it's more than one step problem. So the first step is to convert to what's the intermediate kind of unit here? Feet, right. Feet is in both of them. So that's the first one to calculate too, is going to feet. So we're going to convert inches to feet. Now, this is a hard one you can do in your head, right? We're going to do a setup though. Okay, now we're in feet. Now we go to feet to miles. I'm going to use this guy here. 5280. So we multiply everything on the top, hit the divide sign, and everything on the bottom. And sig fig wise. Okay, so that's infinite, 2. So on this one, again, everything cancels except what we're trying to calculate. Now, your take-home problem may have about 10 steps in it. And when I say 10 steps, I'm talking about 10 conversion factors or so, or 11. I haven't figured out what I'm going to give you yet, but so don't be surprised if you have a lot of conversion factors. It's okay, as long as everything cancels. Okay, are we okay with this two-step problem? How did I get that? I multiplied 12 times 1, divided by 12, and divided by 5280. I'm gonna go, I don't have to multiply by 1 on the calculator, but
Yeah.
so you're gonna go 12, hit the divide key 12, hit the divide key 5280. Enter. Huh? What about 5280? No, you gotta divide by 50, did I? Yeah, you gotta divide by 5280. 80, yes. 5280. Okay, someone else had a question. Just like your calculus class, right? Just like the calculus class, right? All right. Now, I'm using scientific notation here now. On your calculator, most calculators, there's a key called mode, M-O-D-E, or there's actually a key called psi and FLO. Psi stands for scientific notation. FLO stands for floating point. Floating point is without the scientific notation. SCI means your answer will be converted to scientific notation for you. You still got to do sig figs, but most calculators will do that for you. Okay, centimeters and 1.23 kilometers. Okay, on the left goes given. Centimeters goes on the right. So do we have a direct centimeter to kilometer conversion? Okay, what's a good intermediate thing to convert to? Yeah,
This is what I was, could you convert centimeters to inches? And then inches to feet, and then feet to meters, and then you find out kilometers as opposed to meters.
yes. There's another way to do it that's less conversion factors. That'll work though, because everything cancels what you're supposed to cancel. So yeah, you're on the right track. Yeah, yeah, that would be yeah, that was the route I was thinking when I put this problem together. Okay, so we're gonna go, we're gonna get meters. And then from meters, we're gonna go to kilometers. Now, let's go through this metric bit here. You're probably familiar with these four up here already. Computers now are in terabytes. Usually a hard drive, SSD is in terabytes, or your flash drive or whatever, terabytes. It used to be gigabytes. And then your memory is in gigabits. Okay, so mega is just one step down, and these all differ by 10 cubed. So there are 1,000 kilos in a mega, 1,000 megas in a giga, and 1,000 gigas in a tera. But it depends what we're talking about. We're talking about grams, bytes, bits, children, ducks, doesn't matter. Okay, and on the downside, Deci, is anyone in here diabetic? And you prick your finger and measure your glucose level of your blood, it's in millimeters per deciliter. That's how they get those nice numbers. If you didn't do it that way, the numbers would be really weird. It'd be hard to tell whether you're at a good level or not. Okay, so an easy one on this one is how many cents are in a dollar? 100. So there are 100 centis in one. Like if we talk about grams, there are 100 centigrams in 1 gram. Milli is 1,000th. Micro is 1,000,000. And nano is 1,000,000,000. So I gave you examples on all these. I use grams as kind of a common unit. So every one of those has a common unit. If it's mass, it's grams. If it's length, it's going to be liters or meters. If it's volume, it's going to be liters, big L. If it's, what have I left out? Hmm? Yeah, I meant gram, yeah, grams. Those are called SI units. There's an interesting video on I found a couple days ago on the international units called SI unit. They're located, the organization that monitors international units is located in Paris. The guy that invented the metric system made a mistake on calculating a nautical mile. Means a kilometer, but he was off by a little bit. A really tiny amount, but he was off. And they were so embarrassed that they just kept the error. So the error is built in to the international, it's called Système International unit system. Really, I never knew that until I read the article. Okay, so we're looking for, we need to go from centimeters to meters, right? Yeah, centimeters to meters and meters to kilometers. Okay, so remember, always cancel the given. So our first conversion factor is got to have kilometers on the bottom. Otherwise, it won't cancel. And how many meters are in a kilometer? And that is, by definition, and now we're at meters. Now we need to go to centimeters from here. And how many centimeters are in a meter? Yeah, how many centimeters are in a meter? 100. 100 cents to $1. So everything canceled except our centimeters. Now remember, forgot who it was. We're doing dry labs. And they immediately started converting 1,000 into 10 cubed, 100 into 10 squared. And then we would then add the exponents. That works fine too. Okay, So, and our answer is gonna have 3 sig figs. These are both by definition, so anything metric conversion wise, the conversion factors are all infinite. So this whole bottom piece on the conversion handout I gave you, these are all infinite sig figs. Okay, remember what I said earlier, whenever you see the word per, that's a conversion factor for you. Miles per gallon, dollars per gallon. Money, by the way, always has 2 decimal places. So money's funny when you're trying to do sig figs. You'll always put on 2 decimal places or no decimal places. Okay. Let's look at this one now. This is an interesting problem here. All right, what's given? So if the given is a fraction, our calculated form is also a fraction. Kilometers per second. So whenever you have fractions now, you start with a fraction and end with a fraction. You start with linear, cannot end with a fraction. They've got to be the same. Fraction to fraction, linear to linear. Okay, fractions are really 2 problems together. So the first one is we convert miles to kilometers and then hours to seconds, or vice versa. So what do you want to do first? Let's do hours to seconds. So our calculated answer, seconds are on the bottom in the denominator. So we need to have seconds down here. Remember, given always has to cancel. Do we know how many seconds are in an hour? Right.
Wait, did somebody say 3,600? Oh, they said a minute, never mind.
Yeah.
3,600 minutes, right?
Yeah, seconds. No. All right, but we're going to go not directly. We're going to go hours to minutes. Minutes to seconds. Okay, that'll get our seconds for our calculator. Okay, so we need 60 minutes, 60 seconds. Now we need to go miles to kilometers. Okay, got this guy at the top here. It's not boldface. How many sig figs is that? Yeah. Huh? Regarding this? Conversion factors always have 2 versions. No exceptions. Yeah, flip it till it cancels what you wanted to get canceled. And then put the numbers in afterwards. I do the units first. I don't look at any numbers. That makes sense? Yeah. Okay, so 1609. How many sig figs is that? 4. It's not infinite because it's not boldface. So Miles needs to cancel. It's a 1608. Oh, no. Okay, so everything's canceled except kilometers per second. Okay, so that's 4 sig figs. Infinite, 3. So our answer is going to have 3 sig figs. Okay, again, multiply everything on the top. Hit the divide key, everything on the bottom. So we're going to hit the divide key 2 times. I'm not going to do it on the ones unless you're OCD. Then put the ones in. Okay, so we have 34 times 1, 609. Divide key 60. Divide key 60. Enter. And 3 sig figs are answer. So it's going to be you can see how we have was 2 problems in one. Whenever you have fraction to fraction. And it doesn't matter the order, because multiplication is cumulative. You flip it, doesn't matter which one you do first. Huh? No. Did you say 20 is the answer?
It looks confusing. Looks good to see. Yeah.
My answer is confusing.
No, just
The way I wrote it.
oh,
Ah, okay. Better. Okay, is everyone okay with this? We're just canceling the units till we get what we want in the end. That's a little game. You have just conversion factors, cancel, cancel, cancel. Till you end up with what you want. Yeah,
You always want the answer to be.
no, if it's awkward, yes. If it's not awkward for you, leave it alone. On the test. Same thing on the test. I'll look at either will be right. But unless it's a big long number. Now in unit 2, we're gonna get some really giant numbers and some really, really small, for example, the distance from an electron to the nucleus. That's pretty tiny. So that's definitely gonna be a scientific notation version. Same with something called a mole. Mole is 6.02 times 10 to the 23rd. That's 21 zeros. Is that an awkward? Try to put that in your calculator. So my point is, if it's awkward to you, scientific notation, not awkward, leave it. And some teachers have guidelines for you. They'll say if it's less than 0.1, do scientific notation. Greater than 1,000, scientific notation. That defeats the whole purpose of scientific notation, is to make awkward numbers less awkward. Sure. Okay, let's do one more. And this is a good one. Okay. 34 liters per second. Now, this is a problem in the travel industry that travels from country to country. There are 4 countries in the world that use imperial measurements. We're one of them. And the other 3 are tiny, like the Congo. Tiny, tiny country. Then there's giant United States. Now you can blame Ronald Reagan for canceling the metric conversion program. Up until him, we were in the process of converting over to metric totally. And then Ronald Reagan thought it was a stupid idea and canceled the program. All of our street signs are all converted over and all go away. Cars still do kilometers and miles per hour because they're international. Now, being a scientist, I'm very comfortable with metric system. Both cooking, on YouTube, when you look at a cooking show, they'll frequently say grams and centigrade for temperature. Yeah. Huh?
Is there any reason you did that, or did you just feel quirky that day?
He did a lot of quirky things. That's one of the quirky things. And it could be just because he didn't like metrics. I mean,
Never understood it.
huh?
Never understood it.
Yeah. Yeah.
Don't we actually still use the metric system or is it some? Imperial.
Yeah, and engineers use both. Civil engineers still use miles and feet and all that stuff. Sciencey people always use metric. And really, they use the SI system, which is metric is built into that. So physics, geologists use metric. See, even geologists have an issue. Because they'll talk about miles. And they have
Yeah.
yeah, it's okay, so 34 liters per second. That's a fraction, that's a conversion factor given to you. Now I'm going to show you tomorrow a interesting problem that's true. This really happened. There was an Air Canadian flight. Airlines use pounds. Let me back up. Airlines use mass as to the amount of fuel they carry. Because volume changes with temperature. They're not going to use liters or gallons. They're going to use pounds. So in Canada, they're filling up with kilograms, and the United States are filling up with pounds. So if a plane flies from Canada to the United States or vice versa, you're going to issue making sure that what you're loading up is in the right units. Now, big problem happened, I think 1983, 737, they filled it, used the wrong units, and the plane ran out of gas. I'm going to show you that tomorrow. In fact, if you want to go to Here it is. This really happened. The pounds and kilograms are not the same thing. Okay, so we are gonna do that problem tomorrow. Let's do this one last problem. Let's see, what do we got? It's 2 o'clock. Let's just start tomorrow with this problem. Okay, so that's it for today. Now tomorrow I'll continue on with this. And after tomorrow, we're basically done with unit 1. I'm gonna have a review, a unit 1 review, which is basically gonna go over the practice tests. If you go to files, test related, you'll see practice tests. You'll